Hello everyone and welcome to this OLL live event. As Priya introduced, my name is Supriya Anand and I work as a staff curriculum developer in Oracle. In today's session, we will be learning about the new pattern matching feature in Oracle Database 12c. The agenda for today's session, we will be identifying the benefits of pattern matching first, followed by tasks and keywords in pattern matching, and then finally we'll execute a few real-time examples to see how pattern matching can be applied to day-to-day work. Benefits of pattern matching. The ability to recognize patterns across multiple rows is important for many kinds of work. For example, all kinds of business processes which are usually driven by sequence of events. Let's take, for example, security applications where unusual behavior must be detected, or let's say financial applications where you seek patterns of money transfer. Not just that, pattern matching can also be applied to stock charts to identify patterns such as V shapes, W shapes, and U shapes, and the list goes on. So any pattern of interest can be found out using the pattern matching feature as far as we can express the source of the pattern in the form of a table with data in it. Coming to the overview of pattern matching, the match recognize clause is used to perform pattern matching in Oracle SQL. So it is used to first logically partition and order the data that is used in the match recognize clause. So we use the partition by and order by clauses to do this. Then we define patterns of rows to seek using the pattern clause of the match recognize clause. We specify logical conditions required to map a row to a row pattern variable using the define clause, and we define measures which are expressions usable in other parts of the SQL query with the help of the measures clause. So before we delve into the syntax and keywords of pattern matching, let's accomplish a task of finding W pattern in the stock chart which is displayed in the slide. So along with W pattern, we must also find two things. First is the beginning and end date of the pattern, and second, the patterns that lasted less than a week. So without using SQL, an individual or a layman can break down the tasks into subtasks. So the first what you will do is you will identify W patterns in the stock chart, just as I've identified in the slide here. Then you will mark the W patterns to the X coordinate to find the start date and end date of each pattern. And then if there are n number of W patterns, you will use a table to collect the start and end values as we're doing here with the help of a small table. And then finally, you will subtract the start date from the end date to identify the patterns which lasted less than a week's time. So in this example, the first W pattern is discarded as it lasts 9 minus 1, 8 days, and the second W pattern is identified as a pattern of search as it lasted 6 days. So just the way we chunk the task into subtasks and accomplish the objective, SQL also performs the task of finding patterns by chunking it down into subtasks using keywords and pattern matching. Let's have a look at the keywords. So these are the keywords for pattern matching. So each keyword has a unique task and will help you to accomplish a small subtask to identify the patterns. So the first keyword is the partition by clause. It divides the data into logical groups based on the columns specified in the match recognize clause. For example, let's say we may partition the table containing stock chart information by stock names. So what does partition by clause do? For each partition will have a group of rows which is unique to a single stock. So partition by will partition the data based on the column name that you specify, and if you specify the column name to be the stock name, so for each stock will appear as a partition in the table. Next, we have one row per match, which means that for every pattern match found, there will be only one row of output, and then we have all rows per match, which displays all rows which is responsible for a match in the output. So all rows per match is used for a detailed view of the match, and one row per match will give you one single row which constitutes a single match. We have the measures keyword. Measures defines a list of columns that will appear in the pattern output table. So it defines columns whose value will be computed by evaluating the expression related to a particular match. So we also have a few built-in measures to help the developers understand how their patterns is being applied with the help of a match number and classifier function, which we will be looking at in the later slide. Then we have the pattern keyword, which defines the row pattern that will be matched. That is, it defines what pattern we're looking for in a table. For example, in a stock chart, are we looking for a W pattern, a V pattern, a U pattern? So whatever is the pattern of interest that you're looking for in a table will be specified in the pattern using the pattern keyword. And then we have the define keyword, which gives us the conditions that must be met for a row to map to a row pattern variable that you define. So if you look at the previous example, we had X, Y, W, and Z. So what logical conditions should be applied for X or Y or W or Z should be mentioned in the define clause. And then at the end, we have after match skip, which restarts the matching process after a match is found. So these are the keywords of pattern matching. Now let us look at the same example from the previous slide and see how each of these keywords constitutes to find W patterns in the stock chart. First, we have the pattern. It defines the search as X plus Y plus W plus Z plus. So this signifies that we're searching for a W pattern to seek the pattern down, followed by up for 2 consecutive times. So one down followed by up constitutes to a V, and down followed by up for 2 consecutive times forms a W pattern. The plus sign after the pattern variable means that at least one row must be mapped for each of them. So we can call this approach as a greedy approach by saying we have to make sure that the database returns at least one row which maps to each of these pattern variables. So that is what pattern stands for. And then we have the define. So because the pattern clause depends on the pattern variables, you must have a clause to define these variables. So we use the define clause to specify the condition that a row must meet to be mapped to a specific row pattern variable. So here we've defined the pattern variable X to match to rows whose price in the current row is less than the price in the previous row. So this is the logical condition which says the price of the current row must be less than the price of the previous row, and any rows which constitutes to this logical condition will be mapped to X. So if you look at the diagram, X signifies the steep downfall or dip in the price of the stock. Next we have Y. Y matches to rows whose price in the current row is greater than the price in the previous row. So if you look at the stock chart, Y signifies the increase in the price of the stock. Now that we are looking for W patterns in a stock chart, we will use pattern variables W and Z to do the same functionality which X and Y is doing. So W constitutes to a dip in the price and Z constitutes to an increase in price. So all four variables put together will search for a W pattern. Note that the values of the stock chart are loaded into a database with the help of a create and insert statement. So in this scenario, we have the picker table which holds the values of this particular stock chart, and the values of this stock chart are already inserted into a table using the insert statements. Apart from the patterns, there are also a few keywords which are displayed in the slide. Let's study them. Let's start off with the partition by clause. So typically you want to divide your input data into logical groups for analysis. So in this example, the pattern matching is divided so that the pattern search applies to just one stock at a time. So if we think of a stock chart, we will have a lot of stocks which can contribute to a table containing stock information. So we want the pattern to be applied for each and every stock. For this, we partition the stock table by the name of the stock. So partition by specifies that the rows of the input table are to be partitioned by the name of the stock. Therefore, the SQL statement identifies W pattern for each and every stock. So once the table is partitioned based on the stock name, we have the order by. The order by clause is applied for each partition to order values with the partition based on the time of purchase. So within each partition, order by clause is applied, and it orders the rows within the partition based on the time of purchase. Next, we have measures. So measures defines two measures here. The time at the beginning of W shape, which is calculated by using first of X time, and the time at the end of W shape, which is calculated by last of Z time. So the X time and Z time measures use the first and the last functions to ensure that it retrieves the values of first and final value of the time which is within each pattern match. So first of X time will always save the value when the pattern started, and last of Z time will hold the value of the pattern end. So this is required to find the time duration within which the stock existed. So you can apply functions like subtotals, let's say count, running totals, or moving averages in this measures clause. Next, we have one row per match. As highlighted in the slide, if you use one row per match, pattern matching generates only one row for each match that is found. So if you want the output to return every row that is matched, you have to use the all rows per match. So looking at the select statement here, I think we've reached to a level. So in the process of familiarizing with the keywords and the functionality, let's not forget that we are on a mission here to find W patterns in the stock chart with two specifications. First, the beginning and end date of a pattern. Second is to find which pattern lasted less than a week's time. So if we take a look at the SQL statement here, we can see that we have reached a point where the SQL statement has been able to identify all the W patterns in the stock chart. So if we look at the stock chart, we'll see that it's 2 in number, and we can find the beginning and end date of both these patterns. So first of X time and last of Z time variables have the dates already stored in it. Now all we need to do is to find which pattern lasted less than a week's time. For that, we include a logical condition. That is, we define the last condition which says last of Z time minus first of X time should be lesser than or equal to 7, which applies that this condition, we should successfully identify that the second pattern in the stock chart is the pattern of the search. We also have a few additional keywords with pattern matching apart from the mandatory keywords. These are match number and classifier. And these keywords mainly help us analyzing the pattern in detail. So you might have a large number of matches for your pattern within a row partition. So how do you tell apart all these matches? For that, we use the match number function. The match number function numbers the match within a partition sequentially starting at 1 in the order that they are found. So for each partition, the match numbering starts over again at 1. Along with knowing which match number you're seeing, you also want to know which pattern variable applies to which specific row. So for this, we use the classifier function. The classifier function returns a character string whose value is the name of the variable the row is mapped to. So let's understand this keyword more in detail with the help of an example, which I'll be demonstrating now. So if you look at the SQL script here, we have a create table called ticker, which has symbol and which has T-stamp, which is the timestamp, and the price values. Let's create the ticker table of which stores the information of a stock chart and then insert values into it. Once the values are successfully inserted, let's have a look at the select statement, which uses match number and classifier. So if we look at the select statement here, we have a select statement which queries the ticker table, and we're using match recognize to apply pattern matching. And we're finding a V pattern here, wherein we say start the search, where you have down and then an up, constituting to V pattern, and we say we need all rows per match, which says give me a detailed description of the pattern that you find, or for each match give me all the rows which were responsible for the match. And then we have the match number, which specifies the number of the match, and then we have the classifier, which says which pattern variable was responsible for which match. So let's execute the select statement. So if you look at the output here, we have a match number which says for a particular symbol Acme, we have 3 matches, 1, 2, and 3. So the first 6 rows constituted the first match, rows from 7 to 10 constituted the second match, and rows from 11 to 15 constituted to the third V pattern in the table. We also have the classifier function, which is displayed as a variable match column, which states that the first pattern was started at the first row, wherein the price dipped down and then gradually increased, giving rise to a V pattern. Second, we again started the match at row 7, where this row 7 constituted to starting the V pattern, 8 and 9 constituted to downfall in the price or dip in the price, and then we had the 10th row constituting to the pattern variable up, and that ended the pattern. That ended the second pattern. We also have the price associated, which shows that there is a dip and then there is increase for each and every V pattern. So this is how the developers especially apply match number and classifier functions to study each pattern that we retrieve in detail. So next, let's move on to the last agenda of today's event. So I will be demonstrating a real-time example of how pattern matching can be applied to financial transactions. Before that, let's have you answer some quiz questions. Priya?
Sure, Supriya.
Can you please open up the polling question? Yeah.
Sure. Yeah, I've opened up the first one.
Okay. So which function returns the value of an expression evaluated in the last row of the group of rows mapped to a pattern variable. So which function do we have to apply so that we hold the last row of the pattern match is the question. So please take time to answer the quiz question. We've used a similar example in our previous W pattern match. So which function did we use so that we could catch the value of the last row responsible for a pattern? Let's take, for example, a W pattern.
We have received 5 responses so far. I'm just waiting for a couple of more seconds.
Sure.
Okay, I'm closing this poll question now. Supriya, would you like to give up the answer?
Yes. So the last function always stores the value of the last row in a group of rows. So last is the answer for this quiz question. We also have another quiz question. Priya, can you please open that up?
Sure. Yeah, it's opened up.
Okay. So you have a select statement here. So identify the functionality of order by in the following select statement. So note that there is also partition by, and try to analyze what order by does in this select statement which is mentioned here in the question.
We have received 4 responses so far. Again, I should wait for a couple of seconds before closing the poll. Okay, I'm closing the poll now. Supriya, you can give up the answer.
All right. So in this particular query, so order by is used to logically order the rows within a partition, as we already have the partition by clause which logically divides the rows into groups. So whenever there's a partition by clause followed by an order by clause, we say that for each partition the order by clause is applied. Therefore here it logically orders the rows in a partition. All right. So as I said, let's look at a scenario here. So the scenario here is we need to help the IT database folks detect suspicious money transfer pattern for an account, which involves 3 or more small amount of less than $2,000 money transfer within 30 days duration, and followed by one subsequent large transfer with less than or equal to $1 million within 10 days of last small transfer. So when we think of a suspicious money transfer, it's very important for us to define what a suspicious money transfer is. right? So without defining what a suspicious money transfer is, how would you find out that what is the pattern that we're looking for? So if we look at the example or the scenario here, we have a suspicious money transfer, or the pattern of the search defined as 3 small transfers of less than $2,000 within 30 days, followed by 1 subsequent large transfer within 10 days of the last small transfer. So in the report, we want the user ID, the date of first small transfer, date of large transfer, and what is the amount that's being transferred. So this is the scenario here, and we need to help the IT database folks detect the suspicious money transfer by using pattern matching match recognize clause. Let's see how we do that. Before that, let's create the table and insert values. So here, event log is the table which contains information of when the event took place, who's the user who deposited the money or transferred the money, what is the amount that is being transferred, what is the event. So in a financial transaction, there can be deposit, there can be withdrawal, and there can be transfer of money. So these are the 3 events. And then we have transfer to column, which stores the name of a person to whom the money or the amount is transferred to. So make note that when the event is deposit, we will have the transfer to value as null, as we are depositing the amount into our own account. And then when we have the event type as transfer, we will have the transfer to column holding a value. So this is the table with values for a financial transaction. So let's go ahead and insert the values. So all the patterns that we have to look for, we need to look for in a table which has data in it. So for this suspicious money transfer, we have already inserted the table with data on which we are going to perform pattern matching and find a suspicious money transfer. So the table has been created and the rows are inserted successfully. Let's get back and look at the select statement for the suspicious money transfer. Here, this select statement X shows that we have 3 or more small transfers of money with less than $2,000, and the time within which the small transfers have to happen is within 30 days, followed by 1 large transaction of more than or equal to 1 million, and the large transfer must happen within 10 days before the last small transfer. So we have queried the table here, wherein we've queried the event log table here, where we've restricted the event to transfer as we're looking only for suspicious money transfer. We are selecting the user ID, first T, which holds the value of the date of the first transfer, last T, which holds the value of the last transfer, and then we have a pattern which says X with 3 in brackets, saying that we need 3 small transfers. Comma specifies that 3 or more transfers can be allowed. So our specification says that we can have 3 or more small transfer of amount followed by Y, which constitutes to a large transfer. So X is defined as when the event is transfer and when the amount is less than 2000, and Y is defined as when the event is transferred and the amount is greater than 1 million. The last of X time minus first of X time, that is the last transaction of small amount and the first transaction of small amount must be less than 30, so it has to happen within 30 days. And Y time minus last of small transfer should be less than 10 days. So this is the select statement which will come up to find out the suspicious money transfer with 3 or more small amount transfers with 1 large transfer. Let's execute the select statement and find the report that we're looking for and find the person who is responsible for the suspicious money transfer. So we have the same select statement here, which we will be executing to find suspicious money transfer. So according to the pattern that we've specified, John is supposed to be responsible for a suspicious money transfer, wherein he did his first transaction on 6th of Jan and last transaction on 26th of Jan, and the amount transferred of the large amount transferred is 1 million. Let's go back to a slide and update the scenario to find the recipient of the transfer. So we already know who is the person transferring the money. We also want to know the recipient of transfer with 2 more conditions. So in the 3 small amount transfers, we want 2 or more small transfers to happen to different accounts, and then we want sum of all small transfers to be less than $20,000. So we have to update the select statement from the previous slide to make sure that within 3 or more small transfers, 2 or more small transfers should be to different accounts only, and sum of all small transfers should be less than $20,000. Here we've enhanced, or let's say updated, the select statement wherein Z holds a small transfer of amount less than 2,000, which constitutes to 1 small transfer. X says where the event is transfer and the amount is less than or equal to $2,000, where previous of X transfer to is not equal to X transfer to, which says that the person to whom the amount is transferred to should not be equal. And then we have Y, which holds the definition wherein the event has to be a transfer and the amount should be greater than 1 million. And the last condition, which says sum of X amount plus Z amount, that is the total amount of small transfers, should not be greater than $20,000. So if you look at the pattern here, we have 1 small transfer followed by 2 small transactions wherein we do not have it deposited to or transferred to the same account, followed by 1 large transfer. Let us execute the select statement and find the recipient of suspicious money transfer with an additional 2 conditions which we've applied. So we have the same select statement here. Let us execute the select statement to find the recipient. And we see that, yes, the transfer was from John, and first transfer date was 15th of Jan and the last transfer date was 26th of Jan. The large amount which is being transferred is 1 million, and the transfer to has happened to Tim. So Tim is the recipient of small transfer. So this is how pattern matching can be applied to in financial transactions or in stock charts. It also has, it can also be applied to sessions. You can also trace call information. So as far as you can, consolidate and put the information in the form of a table, you can use the select statement with match recognize clause, through which you can perform pattern matching. So there are many more features with pattern matching. So we've just covered the basics of pattern matching, where with few keywords, with mandatory keywords and a few optional keywords. We can also see how we can exclude a pattern from pattern matching, and there are many more features. Please look into Oracle Learning Library for more OBs and videos on pattern matching, which is a new feature in Oracle Database 12.
So this concludes our webcast. Thank you all for attending and have a great rest of the day.